Okay, the same chapter, fluids in motion. Today we'll be doing the next topic, viscosity. Viscosity. What is the meaning of viscosity? We say it is a tendency of a liquid not to flow. It is a tendency of a fluid to oppose its motion is called viscosity. The general meaning of viscosity is, that stickiness. Every liquid has tendency, not to flow. From the tap also you will see the water drop falling down. One drop will fall, suppose. Second drop will fall. After some time, third drop will take longer time to fall down, as slowly, and then ultimately it stops. So a fluid, it is not only applicable for liquid, it is applicable for any fluid. The tendency of a fluid not to flow is called viscosity. In other words, we can take it as a friction offered between the liquid surface. One surface of the liquid, another surface of the liquid, there is a relative motion of one surface over the other surface. Relative motion is there like this. One, this way, the motion is taking place. And due to that motion, there will be a tendency of a liquid not to flow. That, one layer and another layer between them, there will be some kind of friction which will oppose the motion. And who gave a formula, he said, between the liquid force acting and that force which opposes this motion is called viscous drag or viscous force, DRAG, drag or viscous force. And he found that force, F, viscous force, Newton, viscous force, F is proportional to area of the layer of the surface area of the surface layer of the liquid, and it is directly proportional to dV by dx. This is called velocity gradient. Write down dV by dx is called velocity gradient. Velocity gradient. Actually, dV stands for variable velocity and with respect to x, the width of the two layers of the liquid surface. One layer, another layer will be like this. This width is called x. He gave this formula. Later on, to remove this term, he used a constant. That constant is denoted by this symbol, right here, A dV by dx. This symbol is known as, this is constant, this is known as coefficient of viscosity. Please write down, coefficient of viscosity. Coefficient of viscosity. This is read as eta. In class 10, eta we were using for efficiency, but now the same symbol is used for coefficient of viscosity. Every liquid, it's the nature of the liquid to have different value of coefficient of viscosity. Some will oppose more, some will oppose less. The liquid, suppose some liquid will be trying to put it on the floor. You will find the liquid will be going far away. That means that liquid has got less viscosity. But some liquid, when you put it on the floor, it will not go far away. It will be just going little bit only, distance will cover. Because that liquid is more viscous. If I talk about water and any kind of oil, when you put it like this, water will go a longer distance. But instead of that, if you take some oil, maybe glycerin, maybe even this one, mercury and all, any kind of, sticky kind of liquid, sticky type of liquid, mobile and all, when you put it on the floor, it won't go that far because they are more viscous. The opposition is viscous force value is more there. So it depends upon the nature of the liquid, and that's why it depends on the value of this eta. When the eta is high, that means the liquid is more viscous. When the eta value is less, the liquid is less viscous. Okay, now I'll find the unit of this eta. Unit. What kind of viscosity we are finding on unit? See how we are finding the unit. Yes, you are asking something?
For the dV by dx velocity gradient, please.
This dV by dx is for velocity gradient. Velocity gradient. Velocity gradient. Can you guess what can be the unit of eta? What can be the unit? Unit is this way. Eta S by A, force by area will make pressure. That is Pascal we can ask. PA. And dH by dV will make what? Can you guess? X is the distance and V is the velocity. Distance means you can just take distance is meter and velocity is meter per second. Meter will go, this second will come up. It will become P Pascal second, PAS, Pascal second, PAS. This thing is only written as PL. PL is called Poiseuille. 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 So the unit of SI unit of, I'm talking about SI unit of eta is Pascal second. Pascal second. Can you find the dimension of eta? Dimension. I'll find dimension now. Let us find the dimension. Dimension. Dimension of eta. From here you can find Pascal is what? Force upon area. What is the dimension of Pascal? You know, mL minus 2 force upon area is L squared. Second is time. Your answer now will become, this will come on, become L minus 1, T minus 1. This is the dimension of coefficient of viscosity, eta. This has got unit as well as dimension. So please copy. Okay? Yes?
Sir.
You understood the meaning of viscosity? Have you understood the meaning of viscosity? Viscosity means tendency of a body not to flow. Or in other words, you can take it as a friction between the liquid surface. Friction between the liquid surface is called viscosity. And the viscous force always acts in a direction opposite to the motion. Liquid is flowing this way. The which direction the viscous force will act, which will be opposite, this way, opposite direction. A liquid drop is rising up. In what direction the viscous force will be acting? Downward, just opposite to the motion. Okay?
Yes, sir.
Now give next heading. Yeah. Next heading you give now. Okay, write down. Give the heading. Give the heading now, derivation. One minute, I'll just check the syllabus and. Okay. Okay, give the heading derivation of Stokes law. Derivation of Stokes, S-T-O-K-E apostrophe S. Derivation of Stokes law. Stokes law. Derivation of Stokes law. Okay. Write on the derivation of Stokes law. Right. Right. The viscous force. Write down about it. Right. The viscous force. The viscous force F by a
So can you repeat?
You're not audible.
hello. The viscous force by a medium. Just write down the viscous force by a medium on a spherical object. On a spherical object depends on number one, radius of the sphere. Radius of the sphere r. Second factor you write viscosity of the medium. Viscosity means coefficient of viscosity. Viscosity of the medium. Viscosity of the medium theta. And the third factor you write velocity. Velocity of the sphere. Velocity of the sphere v. Stokes found that any spherical object falling in a medium, that medium can be water, can be air, can be any fluid medium, okay? Depends on these three factors. R, radius of the sphere, it depends upon the viscosity of the medium, and it depends upon the velocity of the sphere, velocity of the object which is falling down. What kind of body is that? A spherical body. This is we write as therefore, let you assume that it's let F is equal to first factor is R, second factor is eta, third factor is V with K, and raise the power of A, B, C. We'll apply the method of dimension to find the value of power here, A, B, C. I think we are done in the chapter number 1. Once again, we are using that dimension method. Where K is constant, you can just mention here where K is dimensionless constant. No dimension, no unit. Dimensionless constant. Therefore, you can add like this. Dimension of F will be coming MLT minus 2. K doesn't have dimension. Radius dimension is L. So that L to the power of A. Eta dimension we found ml minus 1 t minus 1. You can just put that power is b. Velocity is lt minus 1 power c. Now we are keeping the power of m, lt all together there on the right hand side. First set power of m. What is the power of m? You can have a look at it. Power of m is only b. Power of l will check. Power of l is coming a minus b plus c, and the power of p is coming how much here? You can see minus b plus c. Now after that, what do? We equate powers. Write down equating powers. I'll do here on top. equating powers. Right here, equating powers. Let us equate the power on both the sides. Value of B becomes 1. Right, and B value is coming 1. L power or here is A minus B plus C, and on the right hand side it is 1. Last one is minus B plus C, and on the left side the power is minus 2. So B value is 1. I'll put the value of B 1 out here and find the value of C. You put here, you get minus 1 plus C is equal to minus 2. Therefore, the value of C is coming Please, once again we'll check. R is radius power A. Eta, what is the dimension of eta? Just check. Just some time back we found it. What is the value of dimension of eta? Tell me, what is that?
Sir, A male minus 1, T minus 1.
Like this only, no?
Yes, sir.
Okay. Dimension of velocity is LP minus 1. B value is coming 1 here. A minus B plus C is 1. And minus B plus C is coming 2. Minus B plus C is coming minus 2. Yes. What answer do you get now?
C minus 1.
This will be minus C out here, no? Minus B and minus C is coming there. So there was a mistake. Minus, like this is there. Minus B minus C is there. Please see, minus B minus C is a minus C, no? There was a mistake. So the answer is coming out, minus C is coming minus 2 plus 1. Minus C is coming minus 1. Therefore, C value is coming 1. I'll put the value of B and C back here in this equation and I will find the answer now. A value, how much we have to find? B value is 1. C value is also 1 is equal to 1. Which will cut? A value is coming 1. All the power value A, B, C is coming 1. I'll put it back. Therefore, F will be coming here K into R to the power of 1 eta G to the power, all 1 power is coming. Or we can write like this, F is equal to K value is Stokes, the scientist Stokes, on the basic experiment, we found the value of K for a spherical object comes 6 pi. K value 6 pi, and that is eta, this is the formula. Right? K is equal to 6 pi by Stokes. Make a note here in brackets. The value of K, constant value on the basis of several experiments, he found, the Stokes found the value of K is 6 pi. So this formula is called Stokes formula or Stokes law. This F stands for viscous force. Viscous force formula on a spherical object, round object is 6 pi eta RB. I give one example. Suppose okay. Suppose we are having a object here like this, and this is the medium. This is the medium. This medium is a fluid medium. It can be water, it can be some oil, or it can be even air. This medium is having viscosity. This medium is having viscosity. Okay, this medium will have viscosity. This medium, fluid has got viscosity. When this one is falling down, then the viscous force will act in the upward direction. Viscous force will be upward direction. Stokes force will act in the upward direction. And when this one is going up, it may happen that it may go up. When the density of this is less than the density of this, the object will be rising up, will be going up. Like for example, air bubble is spherical, underwater rises up because the density of air is less than the density of water. If this one is going up, then the viscous force, if this one is moving up, then the viscous force will act downward, opposite to the motion. Opposite to the motion. So you have to be careful about the direction of viscous force. Viscous force always acts in the direction opposite to the motion, like friction. Understood? Any question in your mind, please clarify. Now give next heading, expression for terminal velocity. Give the heading, expression for terminal velocity. Terminal velocity. Terminal velocity, and in short we write a V with a subscript T, Vt. V with a subscript T, Vt. Okay, what is terminal velocity? Try to understand. For this, we draw the same this diagram will draw. We are having a spherical body falling through a medium. Viscosity of the medium is eta. Density of this medium is rho. Density of this one is d. Density of this spherical body is d. Okay, this one is falling down. Suppose we are taking that situation. This drop is falling down. That is velocity in the downward direction. What will make the body fall down? I'll write here mg. Mg means the weight of the body falling down. We'll see what force will be acting in the upward direction. First force acting in the upward direction will be F. F is the viscous force. Viscous force by the medium. And there will be another force acting in the upward direction, which is upthrust. U. U means upthrust. Upthrust will be acting in the upward direction. Two of the forces are acting upward and mg is acting downward. Yet the body is moving down. How to write on the equation of this motion? You know the equation of the motion, how do we write? This minus this is equal to ma. Normal method, I'll be writing like this here. mg minus u plus f is equal to ma. I have to write like this. But if this this object is falling down with a constant velocity, steady velocity downward. What is the value of acceleration then? 0. Right here for a steady velocity. Steady means constant. For a steady velocity, A will be 0. And that steady velocity with which the object or the spherical object falls down, that steady velocity is called terminal velocity. That is only called terminal velocity. That is steady velocity or the constant velocity with which the object, a spherical object falls or moves through a medium is called terminal velocity. So in terminal velocity term, we can write like this. Right here, mg minus u plus f equal to 0 here. A value is 0. I'll write like this. mg minus u is equal to f. Minus f will go that and become plus f. That means mass. What is the mass of object? Mass formula we write volume into density. For this, I write a volume into density. Density of this object, that is d. Vdg minus upthrust. Upthrust and we write v rho g, because rho is the density of this medium. Upthrust is given by a fluid, not by a solid. This g stands for density of this solid object. and rho or density of the object which is falling down, and rho is the density of the medium in which it is falling. Just now I took the case falling down. And what is the formula of viscous force? Just now we found the formula of viscous force 6 pi eta r v, but this v will be terminal velocity, steady velocity. That's why I am taking a value 0. Volume we can take common out here. Vg is common. Here we get v minus rho is equal to 6 pi eta r v with the subscript vt. What is the formula of volume of the sphere? The volume of the sphere formula we have 4 pi by 3 r cube. And now I write that is 4 pi by 3 r cube g into d minus rho is equal to 6 pi eta r vt. We will cancel and all and make vt the subject of formula. Vt value will come, pi will go. Your answer now will come here 2 by 9 square. And author that d minus rho into g are right here, divided by eta. That is the formula. This is the formula of terminal velocity. This is the formula of terminal velocity. This is the formula of terminal velocity. Okay. If this one is negative thrust, if they think density of the medium is negligible, then upthrust you will not take. Then this is because of the upthrust rho. The rho value will come 0. The formula remains like this. And if the object is going up, that means that these two will be bigger than this. I wrote mg minus g, so that time will become u plus f minus mg is equal to this. Then the value of Vt will come negative. The value of Vt will come negative. Viscous force will act in the downward direction. When this one object is rising up, it's moving up. Then the viscous force direction will be downward. Then we write that mg plus f is equal to u. In that case, we write like that. And then we get answer. That means you need to check carefully the direction of viscous force. When the object is moving up, the viscous force will act downward. And or when we do calculation of the value of Vt, when it comes negative, that means the body is moving up. And in that case, rho will be bigger than v. Rho means density of the medium will be bigger than the density of this object. That will happen. I give another example of terminal velocity. Raindrops. Raindrops, when they are, at a greater height, so they will be having random velocity. But when they come close to the surface of the earth, close to the ground, they all, the raindrops fall down with a steady velocity like this. Steady velocity. This way it falls. Steady velocity. Same velocity. Even from the showers, in the beginning the water speed will be random, but after some time the showers water will be falling down with the same velocity, constantly through air. Such a velocity is terminal velocity. Okay? Yes,
sir.
So this is the formula of terminal velocity. The theory part of this chapter is done, over. And the next class will be doing some numerical problems. And it starts new chapter, elasticity.
For the derivation.
Yes. What?
The derivation is needed for this.
Derivation, no, the MCQ will be there. So probably derivation may not be there, but unless you understand the derivation concept, how can you utilize it? No, that is the thing. Learn the derivation. Stokes formula derivation, just know the formula, okay? And terminal velocity, what is terminal velocity and what is the formula of this? That you should learn. Okay?
Okay, sir.
Yes, sir.
Okay.
Yes, sir.
Then you are adding one more note, one more period. I will be doing problems there in that period. Okay. Thank you, boys.
Yes, sir. Thank you, sir.
Okay.